So good morning, welcome. Thanks for the invite to come in and talk about lab informatics. I recognize a lot of faces here. For those that I haven't met, I'm an analyst with Gartner, which puts me in a very unique position because I often get to see what's in technology roadmaps and what are in plans, for the next couple of years. And we're often at the intersection of business, science, and IT. And we thought that we would kick today off talking about the state of affairs within lab informatics in general. I think when we're thinking about the future and what we want to do, I actually like to use this analogy to set the mindset. We're trying to develop a next generation superiority in a lot of things that we do. And this is the helmet mounted display for the F-35. And what I like about this is that it was designed, sorry, a little bit of a shadow, it was designed with unparalleled situational awareness in mind. That was the #1 design specification for this. So you can imagine it's to help the pilot make faster decisions, better decisions, have more context with information. Every time there's a target on the horizon and it changes the flight pattern, or there are other targets or other potential enemies within a certain environment, the system learns and it's augmenting information in real time. Intelligence from the sea, from the sky, it's connected to the devices on the ground, the things that are on the wingtips, and it does a lot of this in real time. Now, the objective is to give this pilot, an advantage over what, he or she had had before. Now, if you take this, and let's apply this into science now, we're trying to do the same thing. We're trying to develop an unparalleled situational awareness for our research staff or our lab staff. We're trying to better predict what assay data may mean in project terms or in program terms. We also want to augment information over time. How can this leverage scientific data? How can we apply some context and do less experimental repeats? If we're running, for instance, a process or design of experiment, or we're developing an excipient to go into a new drug or a new formulation, doesn't really matter. We have a lot of information. We're firing it over a very narrow rules profile. That's an opportunity to do process improvements. Can we learn from existing data in real time? And we want to connect. We want to connect to our ecosystems. We want to connect to expanding labs. We want to connect to patients more directly or consumers. And of course, we want to be able to do this in real time. We are trying to deliver an unparalleled situational awareness for the people in the laboratory so they can do their jobs better. Looking to the future, there's a lot of technology that's out there. And Peter did a nice job, I think, setting this up. And he already talked about a little bit of this. But big 4 trends right now that are going to change the way that we'll do business. #1 is data science. The data science tools are getting a lot better. #2 is Internet of Things, which feeds in with Industry 4.0 is one. There's several different versions of this, but IoT is everywhere. We're calling it Internet of Lab Things because it is a very specific domain within the laboratory. Artificial intelligence, and then robotics. Those are the big 4 that are going to drive big change. There's some other IT trends as well, but these are the 4 that are going to drive towards that unparalleled lab situational awareness and capabilities for brand new experiences for the different roles that interact. Another concept, keep in mind, digital is coming. Over the next couple of years, really, every time a vendor comes in and says that they have a digital solution, ask them to explain the difference between electronic and digital. Why is this different? And that's a good way to kind of separate out the BS from what's real. Digital does something unique. Digital brings the real world and the virtual world closer together. That's not electronic, that's digital, and it does something else. Interactions, the transactions, now happen between lab staff, the people, the business systems, such as like LIMS and ERPs and other types of solutions out there, and things. These are smart objects, smart devices, live feeds, and so on. That's what digitalization really enables. It develops capabilities where we can model. If we can close the loop with a thing, then we can start to get to a world where we can create a digital twin for our models. And Industry 4.0 leverages this type of thinking, these types of models. So if you could do this, imagine being able to do this for a lab process or for a design of experiment, or if you're developing a new drug or a new device or a new formulation or a new cosmetic. It means that you'll have a better understanding in silico and in the real world at the same time. All right, I'm going to talk about the current state of affairs within the lab informatics market, and then a little bit on planning for the future and how to embrace the technology and make big change. And then 10 steps, they could be in the form of 10 questions that you should be asking vendors here over the next couple of days in order to prepare for this lab of the future environment. Okay, first things first. A lot of vendors in this space. It's a very fragmented environment. There's certainly a lot of enterprise that's out there. But if you actually look at where the vendors operate and what they do, there's a lot of solutions out there that have very specialized workflows. Okay, so there's not a one solution fits all. They don't all compete with the same strengths. There are certainly some lab informatics packages out there that are more geared towards driving innovation. There are other ones that are geared more towards driving quality and production. There's also different industries and sectors, and domain expertise can really matter. Some are more geared towards life science. Majority of the LIMS market's actually been life science focused for such a long time. But we also see LIMS that are very specialized going into other types of industry verticals, so forensics, public health, and so on. There's also different informatics packages that are designed for different types of roles. There are some that are a little more science-based, some that are a little more engineering-based, some are geared towards analysts, some are geared toward production work. And then there are different functional domains. And I think this is where it gets really interesting, because then we can get into talking about full life cycle. So if you work for a company that manufactures a product, can you take an evolving data model and transfer it from the scientific and innovation phase into a design, engineering, and formulation phase, and into quality and into manufacturing, and then into production? Most of your informatics systems that you have today, even at large companies, they're just starting to bridge those different realms. Take this, you have your enterprise vendors at the center, you have your specialized vendors that are niche vendors around the periphery. We're not saying only do enterprise, only do niche. You have to pick your battles, and you have to pick for fit for purpose. But fit for purpose is difficult because there are a lot of different disciplines. There's lots of different lenses that we have to apply to this. And then we have what we call acronym soup. This is one of my favorite recipes here, but a lot of people say, hey, we make an ELN or we make a LIMS, and it's like, well, once you get into the features and capabilities, sometimes they do the same thing, sometimes they don't. But a lot of these, and there are more, by the way, there are probably 20 other that I could cram onto this slide, but there are so many acronyms within this space and competing capabilities that it's often difficult to understand, well, how big should that LIMS be? How large should that ELN be? Should it be a bolt-on? Should it be integrated? Should we develop a services to link the two? Should we get rid of one because it doesn't make sense for the strategic future? So, what are you trying to do? Are you trying to buy an application, or are you actually trying to develop a solution for your business? Now, lab informatics capabilities, the features are continuing to evolve. It would be too hard to fit all this onto one page, but these aren't simple systems anymore. It used to be that an ELN was exactly that. It was a paper replacement, a notebook replacement. They do so much more than that. And LIMS have come really, really far over the last couple of generations. They can do so much more than they did before. It's not just about lab test data. They can do specs now. They can do quality management. They can do so many other things. So when you think about this, and these are some of the I've mixed together the enterprise. I'm not supposed to get into picking apart vendors in an environment like this. But there are plenty of larger vendors that have a fairly large footprint within our space. Those are, for instance, LIMS. We have some genomics-oriented lab informatics packages. We have some of the more traditionally science-based electronic lab notebook and informatics packages and modeling and assays. We have some specific capabilities around chemistry and analytical. We have kind of knowledge management. We have new CRISPR and gene editing tools that are being built into some of these packages. We have new ways of delivery. Certainly we have SAP, which is always in the background. They'll say that they can do a lot of this stuff, if your pockets are deep enough. We have capabilities with some of the specialty lab IT firms out there that often understand lab and data science and science better than sometimes the sponsor staff. And then there's the large IT consulting. In general, I mentioned there's roughly actually about 200 different companies that are battling for your money in this space, and they each bring different capabilities to the market. So some trends right now. I always hear, well, we're going to throw that vendor out, we're done with them. We hear that all the time. Nobody calls Gartner and says, oh, our system's great. It's usually because it's on fire, or there's a problem, or they're furious with the sales rep or with the implementation team. But for the most part, the big enterprise vendors are sticking around. There is better technology, newer technology, new starts and so on. But large organizations, they have to be comfortable, and they only partner with companies that have enterprise scale readiness. You know, if you're running a $2 or $3 billion revenue company, you know, it's hard to convince your manufacturing group that you should go with a smaller vendor. Sometimes it makes sense, sometimes it doesn't. But the fact of the matter is, most of the big vendors, they're kind of sticky. They're going to hang around, you know, and they're going to hang around as long as possible in these environments because the clients are pushing them that way. Another trend within quality and manufacturing, those groups do tend to be much slower in adopting new technology. They don't really change very quickly. And there's a lot of reasons for this, but that's why when you go into large 30, 40, 50 facility deployments on LIMS, you tend to see kind of the same standard approach on LIMS, a bit of a herd mentality within most organizations. But they don't like change. It costs money to make change. Whereas in a research group, they want the latest and greatest. And that's one of the reasons why LIMS and quality and manufacturing is usually on-prem, and it has been, and it will be for a little bit longer. When we get into R&D, if you're a biotech, you want the latest and greatest, you want SaaS, completely different delivery model. Another challenge that's impacting the cycle and adoption, whenever you use the word GXP or validated, we have clients now that, you know, they still walk around with clipboards saying, I need to look at the server so I can check the box on validation. It's like, I'm pretty sure Amazon does better security than your own company. So there are ways to validate in these environments, but culture, resources, and budget are the three biggest hurdles. Culture is actually number one, far and away. Business and IT alignment's always been a challenge. And then here's another interesting concept. The interest rate that you're paying on your cumulative technical debt is ballooning. What I mean by that is that when you have so many different integrated systems together, and you make one little change, or you customize something because that's what the lab wants or that's what the scientists want, you live with that customization forever until you make a change. Customization is your friend, it's also your foe. So you have to be really wise about how you do this. But if you make a change like that, you do customize an environment, it means that someone has to support it. You know, that's difficult to do. 2017 has been a fun year as an analyst. You know, whenever, you know, I see something on Business Wire or you know, over the wire about an acquisition, you know, usually that's when we start to get a lot of calls. This year, Accenture acquired LabAnswer. You have to think about what that means in terms of support, what their capabilities are, if you're partnering with them, what your opinion is of kind of the new combined entity on the lab IT side. Danaher recently acquired IDBS. If you're not familiar with Danaher, Danaher is basically operates as a holding company, but you know, they have Beckman Coulter, they have some other instrument companies in their suite. And now they've gone out and they've acquired a software company. It's kind of similar with what's gone on with some other acquisitions within the space. Thermo acquired Core Informatics, 94 million, I think, based on 10 million in revenue. That's certainly more than three times sales. If that's true, I don't know, we have some Core and Thermo people here today, you know, then maybe it wasn't just for you know, what Core was able to do, but maybe it had something to do with the underlying technology that they may be able to leverage. So looking at these types of acquisitions, you know, do these acts impact your strategy? Because all of a sudden you've partnered with some companies or you've made investments and now they're part of different organizations. There's an upside and a downside to every acquisition. Maybe it means they can scale better. Maybe it means that their P&L has their product lines buried and it's going to be more difficult for them to react to your specific needs. So what's going to happen with their ability to support product innovation, their delivery, their support, their networks? These are things that you have to think about as kind of this market heats up again in the M&A space. Okay, I'm going to shift gears a little bit. This is one of my favorite slides. I've been going to these paperless things for quite a while, and this is somebody's tablet strategy, is where they basically have the tablet and then they put sticky notes on it and they go around the lab. So we talk about writing errors, transcription errors, calculation errors, procedural errors. You could probably tell me which order is the most important. Paperless is often a misnomer. Paperless really just means a replacement of a notebook. There is a whole spectrum of maturity on paperless. In the beginning, a lot of clients that are focused on just the notebook replacement. Around 2004, we saw a lot of activity then, certainly a lot of vendors that were advertising paperless, electronic, and so on. Between 2000 and 2018, we really saw most companies focusing on driving lab efficiency. Today, about 80% of our clients, probably, I think it's a good sampling, represent these level 2 and level 3 area where they're really trying to drive either a lab efficiency or they're trying to drive a lab efficiency with some capabilities and quality. Very few companies are able to kind of achieve this end-to-end scientific lab knowledge management capability. Very few companies are operating there. There's a lot of reasons for that, but that's often what's pitched, that's what's sold. One of the reasons why this is so difficult is because of we're making some trade-offs. On the y-axis here, we have what's important to the lab: depth, functionality, features. Just about every informatics company is trying to sell you on features. We're the best at this, we're the best at that, and so on. And then you have enterprise enablement, which Peter alluded to before. What are you trying to do with this data? Are you trying to drive the business in some sense? So there's standalone point solutions. And a lot of companies deploy this way. Sometimes they do it because they can't afford the integration or they don't know what to integrate to. Sometimes they don't need to. They just want a simple ELN or simple LIMS, and that's fine. You can get deep capabilities with that approach. But the moment that you start to increase your technical debt, starting to drive APIs and integrations, and the professional service teams love this. We all know what the rate cards are for the lab informatics professional service teams. They love this type of work. We'll connect that ELN to your LIMS. Sure, no problem. We're going to put boots on the ground. We're going to charge you a bunch of hours, a bunch of days, and then we'll end up with an integration. And they know the moment that you upgrade that IDBS or upgrade that lab or update that PerkinElmer environment, they make money along those little lines because they got to come back in and they got to update things and get things talking again because we're validated or we're operating in an environment where we're trying to pass information back and forth. The moment you start to do all this, sometimes you lose some of that depth and functionality, but you're enabling the business because now we're getting to sharing some information between systems and expanding that information along more roles. There are a lot of companies that say they have a suite. What the hell is a suite? Well, I think a suite is this. It's when you're taking information, you're having it buried within a bunch of applications. They might have been acquired, so there are certainly a lot of companies out there that have done a lot of acquisition, where they might have acquired a couple of ELNs, acquired a LIMS, acquired another technology. They have multiple data models, multiple architectures under the hood, multiple core applications, multiple workflows. And that's why it's like when you ask, well, can you just unlock all these modules? And they say, well, no, it takes a little bit of work. We got to send out our professional services team. Why the F, and I've heard that language before, why the F blank CK are we doing that? Because you're selling us a suite, a capability, and now we have to come back for professional services to make it work. It's like your PowerPoints are great, but nothing's really talking together. So it takes effort to get those solutions to talk together, especially after acquisitions. And then unified platforms. And this is the direction that we see most of the market trying to go. That's where you have common data models, common code, and so on. So you can see here, as you kind of move along this evolution, eventually you'll get to more enterprise enablement by moving towards either integrated or unified platforms. That's going to be better for data lifecycle. But you begin to lose a little bit of that edge on that technical depth because all of a sudden, you don't have capabilities to have very niche systems that can be tailored exactly for what the lab or science or manufacturing staff need at the time. So there's a bit of a trade-off, and that's the point. You got your lab and you got your business, and if you move in one direction, it usually drags down the other side, and then you have to kind of work to build it back up again. From a market perspective, roughly, almost 80% is on standalone. Sorry, I don't know where the button is for the laser, but roughly, the majority is on that standalone and slightly integrated type app environment. Another component here too, sorry, there's supposed to be a build in that. We got to stop thinking in terms of acronyms. You want to think in terms of capabilities or what you're trying to affect. We talk to a lot of clients and they say, we need an ELN. It's like, okay, why do you need an ELN? Or we need a new LIMS. It's like, why do you need a new LIMS? Let's talk about this for a moment. And you find out that they may need one, but then again, they're also trying to do a bunch of different things. So how are we trying to move the business? You have lab informatics that is definitely more context-centric. You have systems that are more experiment-centric. You have systems that are more procedural-centric, and so on, sample-centric, source-centric, consumption-centric, or system-centric. It doesn't mean that one system can't play in multiple spaces, but there's a center of gravity on these systems, the way that they're rolled out, that kind of optimizes them for different types of work. So do all yourselves a favor, stop thinking in terms of acronyms, start thinking in terms of what you're trying to do for the business. Okay, when you think about that, we're often, this is labs, we're all kind of building from the bottom up. We think about the KPIs or how to perform, what the metrics are for a lab environment. It's usually burden, FTEs, turnaround time, there's some quality metrics. But lab informatics is just one little subcomponent. It's related to quality, it's related to materials, it's related to research, it's related to manufacturing. And all these lab KPIs they stream through these different domains on information. And these are bridging through different functional business domains or functional group domains. And you need to figure out how to tie what you're trying to do within the lab with what you're trying to do to impact your business. If you can do this, then you'll be a hell of a lot more persuasive in terms of trying to get resources and building alignment for why we made the investment in the ELN versus the LIMS or some other types of informatics packages. But this seems, most clients, they're either living in the left world or the right world. And we have to bring those two worlds closer together. Because we're trying to connect very complicated environments, we're trying to connect disciplines, and we have to think big picture in mind. And that's the challenge, is that most of the times when we talk lab informatics, people are coming in very tactically. They're not thinking about it strategically from a business perspective. Now, planning for the future. Taking what we already know, and there's a lot of people here that have some experience in lab informatics and science and IT and so on. There's a lot of text here, but basically we're on this journey. We have today's lab environment. We're trying to move to tomorrow's lab environment to be more flexible, to leverage information as an asset, to be more smart, to bring in new technologies. And there's a lot of technology out there associated with this journey. This is a Gartner hype cycle. So basically every technology that comes onto the scene, it goes through a series of steps. So new technology. So for instance, 3D printing. Oh, cool, now we can print stuff in home, and the media starts to write about it. And then you get some people writing, well, okay, we're going to be able to 3D print livers after we go drinking in the home. Wow, this is going to be great. It's magical. We can do anything we want. We're going to live forever. And then reality sets in, and it turns out, well, it's a hell of a lot harder to print cells on little matrices and so on and keep them consistent. And by the way, vasculatures are difficult, so maybe I'm not going to be able to 3D print my liver in the home. But maybe we should just get rid of this and think about a completely different investment. And that's when it reaches what we call the trough of disillusionment. And then people start to say, okay, we can figure out how to use this type of technology. Maybe we actually can 3D print little different elements. We can do different types of blood-brain barrier assays, or we can print on hydrogels, and we can do those for screening. And then no longer is it really all that differentiated. It's like, okay, it's just another technology. By the time it reaches that plateau of productivity, about 50% of the market has already accepted the technology and is starting to use it within production. So that's the hype cycle. There are a few hype technologies entering the lab space. I've highlighted a couple here. Gartner, we love these things. We have hundreds of these types of documents. But IoT-enabled laboratory, IoT and things. We have IoT in the lab further behind other industries. And there's some reasons for that, but mostly it's because of the infrastructure, and we don't have the skills within this domain to drive this. So we're waiting for some vendors to come up with some solutions, edge IoT analytics, new hardware vendors. Most of the lab informatics companies don't really understand IoT yet. So this is kind of a new discipline that's coming into the space. Blockchain's another fun one. I have blockchain more than 10 years out for having utility within life science. Doesn't mean it's not going to happen in serialization and some other areas, but blockchain in the lab, probably not going to happen anytime soon. But that's getting more and more hyped. You're going to be reading about it a lot. AR and VR and mixed reality actually should be on here as well. A lot of discussion now that there's some new interfaces for bringing in digital twin and AR, VR capabilities into the lab for training, compliance, et cetera. It's starting to get hot. Wearable devices, those are still going up the curve. Individual lab apps, insight engines, inference engines that slap on top of systems for machine learning and for enterprise lab informatics, that end-to-end story that we've heard, those are peak hype. What this means is that over the next couple of years, all these technologies are going to slide into that trough of disillusionment, and maybe we will need 3D printing for livers at that point, because it might be pretty depressing for some companies. And then we have electronic lab notebooks and LIMS, which are much further out. LIMS have been around for a while. They're very well established. Most companies that manufacture anything that's in a regulated environment now, within most of our spaces, they already have LIMS or they already have a lab technology. So those are just a couple of the tech. There's certainly a lot more. Looking back to give us an idea of where we're going, back in 2013, we went out on a limb and we said that most of the ELNs out there in the world are going to need to be replaced because they don't have sustainable service models. I'm going to give myself 4 out of 5 stars on that one. 2018, just about every single client I talk to, they're talking about a challenge with an upgrade or a challenge with a vendor or inability to sustain what they want to do with a business based on the architecture that they adopted. Also, back in 2000, really end of 14, we had a prediction around the number of turnkey solutions out there that for extracting scientific information and pushing it into engineering actions. I'm going to give myself 4 out of 5 on this one as well. And actually, the reason why it's 4 out of 5 is probably closer to 10%, maybe even 5. But if you remember 5 years ago, we had talked about end-to-end process management capabilities where lab and science and all this technology would enable us to move from concept to design to validation to manufacturing, and everything would be great. It's not quite happening yet. Another one, last predict I'll talk about. So we said back in 2015, the majority of scientific R&D organizations are going to struggle to enter into the digital era due to legacy lab system environments, which we're dealing with today, and unfamiliar IoT, so for Industry 4.0. I want this one to sink in a little bit. The legacy systems that we have are dragging us back sometimes in terms of being able to innovate the business. Doesn't mean that you can't innovate within the lab, but the business, and that's what's important. All right, I'm going to give myself 5 out of 5 on that because I think we're spot on. All right, a lot of tech, a lot of cool stuff. I started the talk about lab of the future and all the really interesting technologies. There's a lot of vendors out there with some nice positioning. You don't want to believe everything you see. Certainly, it requires a little bit of due diligence. This is kind of a funny slide because some people interpret this as, oh, what they say really can come true. And it's like, no, there's no bronies or whatever they're called, My Little Ponies. And this is a difficult environment. And if you look at the marketing literature, I'm not going to call out any vendors here. I'm trying not to do that. But we're the category leading lab informatics provider for blah, 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 blah. It's like, okay, insert any vendor there. They all kind of have the same positioning here. So you got to look under the hood. Based on what they offer, how they package, can they deploy, can they maintain, can they sustain, can they help you drive your business based on where you want to go? Here's why. Everyone's talking about artificial intelligence. Every other industry sector already has it. It's finding its way. It's starting to creep into messaging within the different lab informatics providers. They say they have AI for helping you with for science or for drug safety or for process engineering. Well, what kind? Deep learning, ensemble learning, that's used for machine learning. Machine learning is used for artificial intelligence. Artificial intelligence is synonymous with cognitive. Cognitive is a brand. Everyone's seen the IBM Watson commercials, right? That's also an alias for smart machines. This is used for advanced analytics applications. What are advanced analytics applications used for? Well, based on your coding and scripting capabilities and what you've done with data science, now you can move into predictive and prescriptive analytics. All right. So that's a nice way to kind of frame the different clusters. There's 5 different major categories on AI. There's probably 40 different technologies that feed AI, and data science also is a very complex arena. But if you think about how you want to package and how you want to deliver, The reason why you need to understand this is that in order to win with predictive anything, you need the AI and coding capabilities, and you can outsource that to your software vendor or to a lab informatics or an informatics consulting firm, not a problem. But you're going to fail if you don't have internal data science capabilities. So what's the point? You have to understand how to seed and feed. You have to understand the spatial resolution on your data in order to teach the code, the sets, so it can continually evolve as your functions change over time. Okay? It's not easy. This is my favorite slide of the year, actually. There's somebody brilliant out there in the Reddit universe that's intentionally coding chihuahuas as muffins and muffins as chihuahuas. I want to hire this guy and have him work for us. But you know, it's pretty evil. But you know, there's a lot of very expensive data science platforms out there, and these systems are fooled because they can't tell the difference between like the spherical shape of you know, a chihuahua eye and a blueberry. It's like, okay. Everyone's talking about cloud too. You know, yeah, we have new cloud-enabled solutions for ELN and LIMS and everything else. And really, you know, what kind of cloud? You know, so this is another area where you have to kind of dig into this. You know, the future is definitely cloud. Research is not moving as far along as it probably should within a lot of sectors. But I'm not going to go into the details on this, but there are cloud-enabled technologies. These are hosted solutions. Then you have a spectrum where there's cloud-inspired. And these have, you know, gaining some virtualization, gaining some standardization, higher degree of control and touch. You have pure cloud. All right, and this is where we're supporting workflows out in more of a kind of an open environment. And then you have cloud enhanced. There's a whole spectrum here. If a vendor says we can deploy on-prem, we can deploy in the cloud, and we can deploy on SaaS, I say BS. That's not the same code. You can't, and if it is, it's a business model that's going to die in the next couple of years. If you're deploying on multi-tenant SaaS, then there's a spectrum on SaaS, absolutely. But you're doing that in a way where you're rolling out similar code at the same time, keeping everyone current at the same time, and you're eliminating that technical debt component. The moment that they say that they can deploy on-prem too, then your technical debt's going to skyrocket, and you're going to end up with two different code bases at the same time. That's why when you look at the SaaS LIMS strategies or the cloud LIMS strategies that are out there, most of them is not true SaaS. Most of it's just hosted, and they'll change the subscription on it. So understand what's under the hood. Here's another thing. Everybody here that's evaluating a new vendor, you want to look at what we call them market clocks. When a new technology comes out, it starts around the 12 o'clock position. Usually it's kind of exciting, and then it starts to whip around this market clock. In the middle, you have a spectrum of commoditization versus consumerization. You have technology that kind of goes through its life cycle. So for instance, new technology is born. Hopefully this works. You spend time, you refine it, you learn how to scale it, you learn how to operationalize it, and then you need to think about your exit strategy for the technology. Not saying the vendor, but for the technology that might support the vendor. And then ultimately death. If the vendor's not supporting this begin the exit strategy phase, you can stick with them, but the risk profile begins to change. So I think you guys know where I'm going to go with this. Here's one for programming languages. We're starting to get picked apart with this with a lot of vendors. You know, they're trying to understand where's our programming language. You probably recognize a lot of them over here. Here are some of the new ones. Here are some of the, sorry, this is why I wanted the lights down. There should be some bubbles that are showing up around here. And this is what we have entering the dusk of obsolescence. Okay? At some time, we have to think about flushing some of those technologies and then re-energizing what's underneath the hood. Same thing with database management technology. Right now, we're getting a lot of inquiry around blockchain and SQL interfaces to cloud object stores. Kind of on the backside, there's some older DBMS technologies that's built into a lot of your lab informatics products. They're not sustainable. That's why the vendors can't support the change that you want, and the performance sucks, because they can't fix what's underneath the hood. So you have to squeeze the screws. You have to tighten the screws on the vendors to figure out what's obsolete. And by the way, on these clocks, we have time to the next phase, like under 2 years, 2 to 5, 5 to 10, or et cetera. So you have to figure out how to retire some of the older technology and then phase in the new ones over time. And same thing with app dev. I'm not an app dev expert, but I know that we're doing a lot of, having a lot of conversations around container management now and other types of technologies, but it's the same thing. At some point, you're going to have to put some things into the museum, out to pasture, and then think about an upgrade. So work with your vendors, understand their technology strategy. Don't say, okay, those are great features. Understand what's underneath, because their performance will start to degrade over time if they're not addressing what's underneath the hood. That's why we get paid to do what we do. You know, we have to interrogate this stuff, you know, and evolve the technology for our business environments. If you do that, then you can start to think about a future-proof platform, and then you can start to bring in, for instance, some of the new IoT technologies, Elemental Machines, TetraScience, Riffin, Cubist Labs, Thermo's evolving their instrument cloud now. Rockstep has done IoT now for animal labs. A lot of these new IoT plays don't work in the current LIMS or ELN environments because those architectures are not upgraded yet. All right, so we have to think about how we apply these as an appliance over the top. And the same thing with AR and VR and mixed reality. I understand Goodly is going to be here tomorrow. It'll be interesting to hear what they have to say. But there are other technologies that integrate AR and VR into the lab for lab execution, for data science, for procedural execution, and so on. Okay, I'm going to try and wrap up now. I think I'm going over. 10 steps to prepare for the future. And I'll try and go through these pretty quickly. You can turn these into questions for people that you meet with this week, but what do you need to sustain versus optimize versus transform your business? You might have different requirements on this. That means, are you doing a plug-and-play replacement, or are you actually trying to drive big change and take a bigger risk? What are the emerging functional requirements that you have to start building upon? What's going to change? Are you going to be doing more biologics than small molecules, for instance, within your lab environment? What are the business process capabilities needed? What are you trying to affect? Is it an improvement to quality? Is it an improvement to yield? What does success look like in terms of measurable business outcomes? That's where you get into bridging the lab and the business KPIs. What deployment model? Are you going to do this on-prem? Are you going to integrate? Are you going to orchestrate? You know, what kind of cloud? What are the touch points? You can integrate into ERP, into Office. You know, sometimes there are different environments that make sense. And then what do you need from your vendors? Do you want a strategic vendor that's going to grow with you because you know that your business lines are going to change, or do you want a tactical vendor because you have a very stable environment? For instance, within manufacturing, you're doing the same drug over and over and over and over again. And are you comfortable? Now, this is kind of a murky one, but you know, once you start to meet with the vendors and the lab IT groups and the consulting groups that are out there, you know, having domain expertise is pretty important. By the way, most of the consultant groups that sell into your space, they call it, like, if you're in pharma, they call it, well, we're in healthcare and life science. All right, tell me about your projects. Well, we've done pharmacy, we've done payers, we've done providers. So have you ever done, you know what GXP means? You know what CFR means? And if they say no, throw them out, because it's not worth it. Can the vendor solution evolve with you? And the key there is vendor solution, it's not app. What's underneath the hood? All right, take these 10, there might be some more that you can add in based on your other needs. You want to figure out how you can kind of get to that next generation of tech in order to affect a business process or to have a competitive advantage. That's why we're doing this. And then, you know, I'll close with this. We're trying to develop unparalleled situational awareness. We're trying to develop good investments so we can improve our business. And we're in a lot of different businesses in the room here. Some pharma, some consumer. You know, and the way to do that is to think about applying the technology in a way where you're going to affect a business outcome. And there's a lot that you can do here from a platform perspective. Anyways, thank you very much. I'm here for the rest of the day.